Welcome to this walkthrough of Netmon on HackTheBox. This is the second of our series of 10 machines exploited without the use of Metasploit wherever possible. In this case, we have one main route to system access, first with user-level access and then escalating that to system administrator-level access. So as usual, we'll begin with Nmap, using our usual SC for the scripts, SB for versioning, and TAC for scanning all the TCP ports. This will take just a minute or two, so pause, and we'll return as soon as the results are back. All right, and we're back. And we've got our results. So it looks like we have a number of ports open. We've got FTP open, and it appears that we have anonymous login allowed. It also shows us quite clearly that we're dealing with a Windows system, as it's offering up to us the C drive and its contents. We have port 80 running an unusual HTTP server, running this Paisler PRTG bandwidth monitor, part of the PRTG network monitor system. We've got ports 135, 139, 445. So we're running we've got some NetBIOS ports open for an SMB share. On ports 5985 and 47001, it appears there is HTTP API, so an API connection of some kind. And a bit of research shows us that this is for the PRTG network monitor. And then a number of Microsoft remote procedure call ports open in the high ephemeral range. So we're looking at a Windows machine, probably server 2008 R2 to 2012. As we look at the SMB security mode, signing security mode, we see that message signing might be disabled. Up here it says that it's disabled. It looks like it may actually be running SMB2. And in this case, message signing is enabled, although not required, which could still be a problem. Looking quickly then at our FTP server, we can see that we have anonymous access, very easy access to a fair portion of the files on the system, although not necessarily many files to look at. Or full access to all areas if we were to hunt around in all of here. Our first step, though, from our standpoint here, is to have a look in the access of the users area. We see we can access that, we can access the public area, and right off the bat, we've got our user.txt file. And we can actually view it there directly. Backing off, though, we see that we don't have access, no matter how many times I click it, to the administrator area. So we don't have permissions for that. Now, if we were to do this on the command line, it wouldn't look much different. We would be logging in as anonymous, and then just any empty password is fine. And then we can provide it with Windows command line commands to navigate around. We can see that we're in the C directory, C users. We can go into the public area again, but we could see if we can try to get into the administrator area. And it says 550 access denied. Okay. So we have partial access to the machine, and perhaps a route then to gain a greater foothold in the machine, although nothing directly through the FTP at the moment. But we have the rest of the system to look at. And another place we might have a look is the HTTP site that it's serving up on port 80, which, as we can see, is the PRTG network monitor login page. Now, a bit of Google searching will tell us that there is a set of PRTG default credentials floating around out there. This directly from the Paisler website. The default credentials they have are login PRTG admin, password PRTG admin. So we could try that. It says our login has failed, however. So they've at least taken the step of changing them over to something else. Our question right now then is, can we locate any credentials on the system? And a bit of further research will lead us to this bit of documentation on the Paisler website, specifically about our version. So in this version, we're in 18.1.37. Here we go, 18.1.37.13946. That version and earlier versions of PRTG Network Monitor have the possibility that it is storing credentials in plain text in some of the configuration files. So the documentation tells us to look in these areas here, so the C program data area. If we go back to our FTP, we don't see program data in this set of options. But if we simply try to navigate to it, we can see that it's present, it's simply hidden. Okay? So we can force browse to it. And we can see the Paisler directory, PRTG network monitor directory, and we can see we've got a series of backed up configuration, old and backed up configuration files. So if we go back into our anonymous FTP access on the command line, we can also browse to that PRTG, to program files, or program data. We can see it there. We can navigate into Paisler, and we can CD into the PRTG network monitor folder. We have to keep it in double quotes there because there are spaces in the folder name. And as you can see, I'm switching back and forth between dir and ls. Technically, it's a Windows system, but FTP will allow us to use both ls and dir commands. And just reconnecting as anonymous, we go into our directory here, and we can see that we can quite easily get our 3 PRTG files. PRTG configuration .dat, .old, and .old.back. So if we quit out of there, and we were to simply cat one of these files, we can see that its output is quite large, as we can see. It goes on for pages and pages and pages. What we can see, though, is that there is login information about the PRTG system administrator, this PRTG admin, but in this case, in this file, the password is encrypted. And so we've got this password, encrypted password or hash password, which isn't much use to us. When we get to the old.back file, though, we can see that there are some plain text credentials in there. We're grepping for that PRTG admin name. So the administrator ought to have removed these files, according to the notification from Paisler about the vulnerability in this version, at least if they were going to stick with this version. Also, these shouldn't really be accessible to us, but they are because the FTP is set to allow anonymous access. So we have security misconfiguration issues in that the FTP server is set to anonymous, that we have permissions to enter these directories, and that these files haven't been removed. Now, if we go to our network monitor login page, and we provide it with that PRTG admin username and PRTG admin password, our login is still going to fail. So they've changed it since that backup file was created. But as we can see, this password ends in 2018. And passwords that end in dates, years in particular, they usually do so for a reason. And that reason is laziness and sloppy password management and hygiene. So if we go up a year, PRTG admin to 2019, we find that it does indeed work, and we are into the management system as the system administrator. So that opens up a possibility for an exploit of the PRTG network monitor itself, which it turns out does contain a way to inject operating system commands through sensor notifications. The way that it handles communication requests for sensors, there's an opportunity to inject some code. Now, we're not going to do that manually, although that is a possibility. We're not going to do it manually because there is a script out there for us to do it for us. If we have a look for it in ExploitDB, search for PRTG, and we can see that there are 3 known exploits. We don't want a denial of service attack, so the Stack Overflow is not going to be useful. There is this one for Traffic Grapher, version 6.2.1 of that component, cross-site scripting vulnerability, but we're not even sure that we have that component. We do know that we have Network Monitor in 18.2.38 or earlier, and this is a remote code execution vulnerability, so that's ideal for us. So we could download that code directly for that vulnerability right here, or we can find it in Kali using Searchsploit. Just searching for Searchsploit PRTG. We get the same set of results. These are linked databases, and because we have a path here, we can see that this is 46527 is the name of the exploit. We can have that brought to our current directory. And that lets us have a look at the code. So looking through the code then for this exploit, we can see there's just an opening banner, tells us to log into the app, that there are default credentials available. They don't work, but we've got other ones. And once we're authenticated, we take our cookie and we use it with the script. And once we do that, it will create a new user pen test in the administrators group with the password P3NT3ST exclamation mark pen test in LeetSpeak. This is the basis of the code, so echoing back our usage example. It's creating a file. That file is some PowerShell script that's going to be added up, brought up to the server, and will create the user, add them to the administrator group, and let us know when it's done. So we can start by making that script executable. We need to grab our cookies. So we are logged in to the Net Monitor, and we can just go into the Web Inspector tools under Web Developer Inspector. At least this is where it is in Firefox, and in Firefox cookies are kept in the storage area. So we can see our 4 cookies that are required for this this system. The GAT cookie, which is just set to 1. We can grab our _GA cookie. We can grab our _GID cookie. And we can grab our octopus cookie. And with that, we can build our command. I'll just clear my screen here so we can see the results. So we're going to run this in bash. Here's the name of our script. We'll give it the -u option to give it the URL of the site that we're attacking. The -c to give it all of our cookie information. And we get a syntax error, which is easy enough to correct. This is because we've got carriage returns, the /r, so Windows line endings, in a script that we're trying to run on a non-Windows system. And we can fix that quite easily with the sed command. So in this case, we're just replacing the /r at the end of the lines with nothing at all. Give it the file name. So we've got that fixed. We could go in and manually edit. This is much easier. And we run the script again, and it's created our file. And so our PowerShell script that will ultimately create the user, it's running that now. So it's adding the new user pen test with the password pen test, and adding that user to the administrators group. So we have full administrative access, and it's completed. So in order to make use of our newly minted credentials, we're going to make use of the psexec.py script, which comes with the impacket set of networking tools for Python. This is really just a Python version of the psexec tool in Windows sysinternals, which is a lightweight telnet replacement. It allows you to execute processes on other systems and then outputs the responses back to your local terminal. There are other similar tools, wmiexec and smbexec, which provide less fully interactive shells, but which I'm told are less likely to be caught by IDS and IPS in an actual client engagement. We're not concerned with stealth here, so we can provide psexec with our credentials. So psexec.py, pentest is the username, and then a colon, and then we'll put it in quotation marks just to keep any strange characters from causing an issue. We give it pentest exclamation mark, and we're doing this at 10.10.10.152. That's the system that we're attacking. And there it goes. And it's found access. And if we were to run the whoami command, you can see that we're logged in as NT-authority/system. So we have the Windows equivalent of root access on this machine. So if we back all the way out and move into the users area, we can enter the administrator directory. We don't see the root.txt here. But we can search for it. So similar to the find command, we can run dr/s and look for any results with root. In this case, we see that it is in the desktop folder, which we would have found, but saves us a little bit of hunting around. And we can view the contents of that file. Okay? So this is a series of both misconfigurations and out-of-date software. The first misconfiguration, of course, was that the FTP service allowed anonymous access. And that gave us the ability to go looking around for any set of credentials that we could make use of. In this case, we were looking specifically for the PRTG administrator that we were able to use with some modification. So it's poor password hygiene to simply increment the year on what was otherwise a reasonably complex password. It had uppercase and lowercase characters, it had numbers, it had symbols. But because it ended in 2018, it wasn't a great leap to say that perhaps it had been changed to 2019 the following year, and perhaps 2020 this year, if this was a real current production system. With those credentials, we're able to log in as the system administrator and take advantage of an out-of-date software version that has a vulnerability, allowing us to create a new user on the machine through a PowerShell script uploaded through a sensor notification. ultimately, we were able to log in with those new credentials using the psexec tool from the Windows sysinternals, or at least the Python version of it running on a Linux machine.